Hello and welcome back. This is Barrett from the C4 Cyber Club here at Cypress College. And in this video today, I'm going to cover the Security Plus Lab series, configuring a network-based firewall. Now, what we're going to do, excuse me, we're mainly going to be working with this Kali machine and the Ubuntu machine, and we're going to see how these communicate between each other, how we could change the rules on the pfSense firewall to disallow inbound connections, and we'll talk about why you would want to do that. And for those who don't know, the pfSense is an open source firewall. It's a software firewall that you can set up on like a virtual machine or on a physical computer as well. PF generally stands for packet filtering. So that's essentially what a firewall does. We're filtering packets based on either a protocol or maybe based on an IP address. And in this case, we will definitely be looking at filtering based on the ICMP protocol, which is used to do ping requests. So let's get started. This is kind of a long lab. We'll also get into configuring a VPN in the third part. It's long, not necessarily hard, but it's just a lot of rules to set, a lot of configurations. But by the end, you will have a very good handle on firewall rules, why ping is useful, and how we can set up a VPN. Great. So in the first part of the lab, let's go ahead and launch the Ubuntu machine. We'll go into terminal. And let's ping the Kali machine. Oops. 203. Oh, we're going to do a count of 4. 203.0.113.2. Okay, so you can see those pings: 4 packets transmitted, 4 received, 0% package loss. And we can see that we're pinging the 203.0.113 network, the .2 host, which is the Kali machine. So we just sent a ping request through the firewall to the Kali machine. Now we're going to come to the Kali machine and let's see if we can ping the Ubuntu machine. We'll do a count of 4 again. 192.168.1.50, which you could always double check. That is the .50. This is the Ubuntu machine. And we see that we are successful here as well. So currently we could say that this firewall is allowing inbound connections, and it's also allowing outbound connections, and specifically on ICMP. Okay, so let's go to the Ubuntu machine and let's launch Firefox. And what we're going to do, we're going to access the pfSense firewall through the web browser. We're essentially connecting to it at 192.168.1.1, and it's going to ask for a username and password. So this is how an administrator could log in and change the firewall rules. So we'll enter an admin, pfSense is the password. And so here you see we have the dashboard for the pfSense firewall. So let's create a rule and let's see if we could block some of those ping requests. So come to Firewall, go to Rules, and we'll want to click this plus sign here to add new rule. And let's say we want to block. So we want to block all ICMP protocol. And we don't want this coming from the Kali machine. So we're going to block from this source right here. Okay, so you set the source type to network, and then we're going to designate the 203.0.113.0, and we'll TAC 29. We can get that from the topology page here. And let's go ahead and save that. And then very important, anytime you add a new rule, make any changes, you want to apply the changes up top there. Very good. Okay, so we could see here, we've set a rule for ICMP packets from the source 203.0.113.0, and this will be a block, which is designated or denoted by the X, the red X there. So let's go back to the Kali machine, and what do you think? Do you think we'll be able to ping this? Actually, I'm just going to press the up arrow, bring that last command back. Okay, and it's obviously thinking really hard. It's taking a little bit more time than last time. Okay, 4 packets transmitted, 0 received, 100% packet loss. So we could see that those ICMP packets were blocked because we created that rule. So let's say if you are maybe doing a penetration test and you are scanning for open ports, or you're oftentimes the very first thing that's done is to send a ping out. Like it's called a SYN flood, where you just send out a bunch of you send out a sweep, and you're just looking for anybody to reply. So that's why most firewalls will disable or block ICMP ping requests to add a layer of defense. However, we could probably poke around a little bit more with Nmap. So let's take a look and see if we could find out a little bit more information. So we'll run Nmap on the firewall, and we'll see what kind of ports are open there. Okay, and we see that we have port 53 open, which is used for DNS, and we have port 80 open for the web server. And we also came to learn a MAC address, which is the physical address of the firewall. Okay, let's come back to the Ubuntu system. And we could set up a port forward here so that if we choose to SSH into the firewall, it's going to have us redirect that traffic to the Ubuntu machine. So let's come to Firewall and NAT. We're going to add a new setting here. The destination port range, we want to set both of these to SSH. The redirect target EP is going to be that of the Ubuntu machine, so 192.168.1.50, and the redirect target port is also SSH. Okay, we'll go ahead and save that. And remember, after you add any new rule, you always want to apply changes. And we'll go ahead and close this. And we could also see immediately, now that we essentially created a new service on the firewall. So I'm going to run that Nmap again, and we could take a look and see what has changed here. Great. So now you could see that the service SSH on port 22 is now open because we created that port forward. So in that case, we could say, okay, let's see what we can do there. So I'm going to SSH into the firewall IP 203.0.113.1. Okay, and it's asking me for the password. So let's say we knew this, we know it's a secure password. And now you see that we have a shell prompt here. It's root at Ubuntu. So we are currently connected to this machine here because we SSH'd into the firewall IP, but because we have this port forward, and on SSH, it forwards any SSH traffic to the Ubuntu machine. So with that in place, let's pretend this isn't anything nefarious. This is not an attacker, but just the network administrator that set this up so that they can SSH into the Ubuntu machine from the outside, from this Kali machine. And we could also verify this a little bit more. So if we used ifconfig, we could see that from this prompt, when we run this command now, this is the IP address, which is the Ubuntu IP. We could take a look at the routing table, which I should say also, this is if we were a malicious attacker and were able to get in and SSH into a machine like this, running these commands is a form of further information gathering and enumeration and learning more about the network, which would help an attacker gain privilege escalation, on a network. It's always kind of good to think about both sides, when you're working on these labs. So let's run an Nmap on the internal network. Now keep in mind, we are running on an external machine, SSH'd into the Ubuntu machine in the internal network. And now we're running an Nmap on the firewall on the inbound side. So let's see if there's any other information that we can gather from that kind of scan. Okay, and we do see one other service here, Squid, running on port 3128. So not a whole lot different here, but it's nice to see, or it's good to see how different scanning, especially when it comes to Nmap, scanning from different sides will usually give you more information, or different information, I should say. And scanning from the outside, this would usually be considered a non-credentialed scan. You're from the outside, so you are at the mercy of all of these firewall rules, and typically you're going to have network administrators that are trying to block you from doing anything bad or poking around. But then if you are able to get inside and you do more scans from the inside, this is what's considered a credentialed scan. It's kind of like you hear the phrase insider threat, but it's when you scan from the inside, you can usually glean a lot more information because there's not as much blocking outbound traffic. Okay, so let's move on to the final part of the lab, configuring a VPN on the pfSense. So we will come to the Ubuntu machine where we are logged into the administration panel here. We will come to System and Cert Manager. So essentially what we're going to be doing here is creating our own internal certificate authority. Certificate authorities essentially are what issue digital certificates. It acts as a trusted third party in verifying certificates. So, and we will also be creating separate certificates for a user, so that essentially whenever that user connects via the VPN, this certificate authority that we're creating will be able to verify that they are who they say they are, because essentially we'll be giving that outside person access to the internal network. So you want to make sure that they are, you want to make sure that that digital signature still holds the integrity, so that you could verify. Okay, so once we're in here, we're going to go ahead and add or import CA. So we're essentially adding. Let's call this my CA. For method, we're going to create an internal certificate authority. We'll keep the key length at 2048 bits. This will be using SHA-256 encryption. Distinguished names, so we'll just add what the lab has here. City of Texas, Austin, organization is XYZ, email address admin@xyz.corp, and this is an internal CA. Great, so that part's done. We'll come to certificates, and we will create the server certificate. So this will be the VPN server certificate. We're going to create another internal. You see here let's give it a name, VPN server cert. And you're going to see the certificate authority is that new internal CA that we created. We want this to be a server certificate. And we'll keep all of the name information, except for the common name. We'll change that to openvpn.xyz.corp. Save. Okay, and now finally we need to create a new user. We'll come to System User Manager. Click the plus sign to add user. And let's name him Bob. Give him a password of bpassx. Full name is Bob. Click to create a user certificate here. Looks like we're good on all of the other settings up here. Certificate authority is my CA. Give it a name of Bob Cert. And hit save. Okay, now let's come to VPN, open VPN. Go to the wizard. This will allow us to create the VPN server. The certificate authority you could see is the MyCA internal certificate. The server certificate here is VPN server cert. And we want this to be internal. We'll use UDP protocol, which makes sense. We want fast connections. This will be a connectionless setup for those familiar with networking. And description, we would just call it my VPN server. Okay. And cryptographic settings. So we definitely want the VPN to be encrypted. It's looking like by default, it's using TLS. Very good. Let's change this down to 128 bits CBC right here. And we have no hardware crypto acceleration. Okay, so tunnel network, we have some settings to add here. We'll give it an IP of 172.16.1.0, ACK24. Redirect gateway is checked. Force all client generated traffic through the tunnel. That we want to force all of the traffic to go through the tunnel. That way it's all encrypted. Local network 10.1.1.0, ACK28. We could have a maximum of 10 concurrent connections. Compression, we will enable with adaptive compression. And just to verify some more settings, dynamic IP is checked, address pool is checked, so it will provide a virtual adapter IP address to any clients connected. Okay, and now we choose next. And here, this is important, we can just go ahead and automatically create a firewall role. So add a role to permit connections to this OpenVPN server. And we will add an OpenVPN role to allow traffic from connected clients to pass inside the VPN tunnel. Okay, your configuration is now complete. Very good. Now let's go to client export. Remote access server is my VPN server. Hostname resolution, interface IP address, verify server CN. Looks like that is correct by default. And we are using a random local port for this connection. And we will use a password to protect the BKCS12 file contents. This is essentially the certificate file. So let's do bpassx as we did use as a password before. Okay, and now we come down to client install packages. So we want to click on archive here. And this is going to download the certificate for us. Save that file. You'll see that that has saved in your home student downloads directory. So let's go there. Let's open up terminal. Okay, cd/home student downloads. ls, we could see, okay, it looks like there was one or a couple already residing there. Unzip pfSense. And here's a good Linux tip. If you have a long, kind of a long file name like this, you could start to type and then hit tab, and you'll see that it will start to autocomplete that file. Now you had to kind of type some more because it got confused because there's a couple of them. And we'll just go ahead and say all here. Let's replace all. What I think happened is, let's say yes. This virtual machine must not have completely reset or wasn't set to remove this. So this is pretty much from previous attempts. So no worries. Feel free to overwrite this if this happens to you as well. And if we ls again, we could even go take a look in that folder. And remember, if you see blue, this means it's a folder. Red is an executable file. So let's go into pfSense UDP 1194 Bob. Oh, I misspelled it. There we go. And now you see this is we have this file in here. Okay, so let's go ahead and choose this new VPN connection that we created. We're going to configure VPN. Under network connections, we'll choose add. Or no, I'm sorry, we want to import. So we're going to import from the downloads folder, and we're going to move into the pfSense-UDP 1194 Bob folder, and we'll select the .ovpn file here. All right, and the gateway is 192.168.1.1. Our username is Bob, and we remember our password is bpassx, and the private key password we also kept the same. which I'm sure you realize this is terrible password policies, but obviously for the ease of the lab, make it easy. And that's all. We're going to hit save. And you see that added there. We'll hit close. Now let's go ahead and make that connection. So we'll go back to VPN connections. Select the pfSense UDP. We see it connecting up here. Okay, VPN connection has been successfully established. And we could verify this if we pull up terminal and let's run ifconfig. And now you will see we have our usual ETH0, we have our loopback, but now we have a TUN0 interface, which stands for tunnel. So this is our new VPN connection, and we have a IP address of 172.16.1.6. Okay, so let's switch back to Firefox. We will come to, where's status? Here we go, status. We're gonna take a look at system logs. Oops. Take a look at OpenVPN. And we could actually take a look at Bob's authentication, in the logs here. And if we take a look at the status of the OpenVPN, we could see active connections. So we could see that Bob is connected here. Here's the real IP address, which we know is coming from the Ubuntu machine. And here is the VPN virtual address. So that is everything. Lab 11, Security Plus Lab Series, configuring a network-based firewall. We covered pfSense firewall, or packet filtering firewall. And we talked about ICMP, why it's a good idea to block inbound ICMP ping requests on the firewall side. And we set up a VPN server at the end. Thanks a lot for watching.